Hello, in this video let's discuss second and third question of today's contest. You are given an integer and nums. A pair of integers is called perfect if the following conditions are satisfied. The minimum of absolute value and of sum and difference is less than or equal to minimum of both. And similarly maximum of those both should be greater than or equal to maximum of both the values. Return the minimum number of distinct different pairs. The absolute value is the non-negative value of x and the conditions are n is up to 195 and the values are up to minus 199 to 199. So firstly, let's say these two are the given conditions. Let's assume some basic values and let's get what are the real equations required. Let's assume a is greater than b and both are positive. So then what will be the given equation? It will be minimum of this difference and sum. As both are greater than 0, the minimum will be less than maximum. And as we assume that a is greater than b, mod a minus b will be positive. So it will be simply a minus b. So a minus b is less than or equal to minimum of both, which is b. And for this coming to second condition, the sum is maximum. So it is a plus b and it should be greater than or equal to mod of a, mod of maximum, which is a. So second condition is always satisfied because we assumed that b is positive. And then from this we got that a is less than or equal to 2b. And for now let's assume second condition where a is greater than 0 or b is less than and b is less than 0. So from this, and let's assume that mod a is also greater than mod b. So for example, a is 7 and b is minus 3. And then what can be the given equations? They are minimum of a minus b, which is minimum of 10 and 4. So the minimum of this is 4. So which is mod of a plus b, which is a plus b. So a plus b is less than or equal to minimum of those both, which is equal to minimum of 7 and 3, which is equal to 3 and which is equal to minus b. So a plus b is less than or equal to minus b. And second condition is a minus b greater than or equal to a. So second is always true. And the first one is a is less than or equal to minus 2b. So from this, these two are the equations formed. For example, when mod a is greater than or equal to mod b. So mod is greater than or equal to b. Then from this what we got? Here it is a is less than or equal to 2b and here it is less than or equal to minus 2b. So it means that it is simply mod a is less than or equal to 2 into mod b. Because if b is positive, this is the condition, and if b is negative, this is the condition. So it is simply mod a is less than or equal to 2 into mod b. If mod a is greater than mod b, because here we assumed that a is greater than b here and mod a is greater than mod b here. So both these can be understood as mod of a less than or equal to 2 into mod b if mod is greater than mod b. And similarly, we can find other two cases where mod b is greater than mod a, and then what is the final condition? It is simply mod a greater than or equal to 2 into mod b. So from this we got that we want the pairs a b such that the maximum of this both is less than or equal to 2 into minimum of the both, so that we can get the given condition. So how can we get this? So from this we also understood that the given values are not important, only the modulus values of those are important. So make a new vector where each value is the mod of value of that index and then sort the whole array, because we can use binary search to find the right index. So make a new vector, and for example we have big array and we are at this index example I. So we want, let's assume that this is the minimum value and we have pair I and j, and I should be the minimum value of those both. And then what is the range for j? It should be less than or equal to 2 into minimum value. So for this, from index I, we can use binary search to find the upper bound such that the maximum value is 2 into v of I. So if we are at index I and the binary search of the upper bound of 2 into v of I is j, then what are the indices that I can form a pair with? It is I plus 1 to j minus 1. Because for example, let's assume that we have 2, 2, 3, 4, 4 and 7. This is the value of I. So for this index, what is the other pair which can be satisfying the condition? So for this 2, it is only up to this 4. Because if we reach this, it means that it is greater than 4. So we cannot pair this because it will be less than or equal to 2 into 2, which is 4. So the upper bound of I is this one, 0, 1, 2, 3, 4, 5. So upper bound of 0 is 5. So the indices for which I can pair with is I plus 1. We cannot take I and I because it is given that we have to find two distinct indices. So for I plus 1 to j minus 1 is the required answer. And what is the count of this? It is j minus 1 minus I plus 1 plus 1. It is I minus j minus 1. So we can simply loop and we can find the, initially we are pushing the v1 with absolute values and then start from 0 to n. For every index I, do the upper bound of 2 into v of I, and then we will get the index I. So it means that v of I is more than twice of v of j. So the required is I plus 1 to j minus 1, and this is the answer which can pair with j. In this way, you can find the answer for the first one. Let's discuss the second one. You are given a directed weighted graph with n nodes labeled from 0 to n minus 1, and edges ui, vi, wi represents a directed edge from ui to vi with a cost wi. Each node has a switch that can be used at most once. When you arrive at ui and you have not used its switch, you may activate it with one of the incoming edges, reverse that edge to reverse the edge, and immediately traverse it. The reversal is only valid for a single move, and using a reversed cost of 2 into wi. Return the minimum total cost to travel from 0 to n minus 1. If it is not possible, return minus 1. The constraints are n is up to 1 if I and w is up to 1000. So from this, if there is no restriction of reversing edges, it is very simple dice. But here, for every edge we can reverse that edge at most once, and then we can traverse that with twice of the initial weight cost. So for example, if we have 1 and 2 and the cost is 3, we can traverse from 1 to 2 with a cost 3, or we can traverse from 2 to 1 with a cost 6 also. So we have other choice also here. So we cannot directly do dash try here. But when there is a possibility that we can reverse an edge, for example, we have 1 to 2 and we have 2 to 3 and we have 3 to 4 also. So in this, is there any possibility that we will reverse this edge and we will traverse twice? Obviously no, because it will surely increase our answer. So in this case, there is no possibility of reversal also because it increases our answer but not decreases. So in which cases we can reverse the edge? Obviously we can reverse only if we think that there is no path. For example, we have if this is the given graph, and then we traverse from 1 to 2 and we travel from 2 to 3, but there is no path to 4. So in this case we can try to reverse it. And is this the only case where if there is no path we can reverse the edge? Surely no, because there can be a case where, for example, the it is 1 2, for example, this is the given edge and given graph. We can traverse from 1 to 2, 2 to 3, 3 to 4. But what is the total cost of this? It will be 3 plus 4 plus 5, which is 12. But what if we try to just reverse this with a twice of 2, with a cost of 2, and then the cost is 5, which will be 3 into 2 plus 1. So even if there is no path, even if there is a path between u and v, initial 0 to n minus 1, we can use some minimum edge, we can use some middle edges before, and then we can twice that, and then we can get the least answer. But we cannot try for every edge. So from this, if we try to take more examples, it is clear that A to B an edge with W weight is simply equal to A to B with weight W and B to A with 2W, because we can use 2W or we can reach A from B with 2W, even though we may not use this. But what if the every edge is decoded as double edge? Then we can directly use dice, right? So even in this case, even for this even for this one, for example, we have 1 to 3 and we 1 to 2, we have 1 to 2 with weight 3, so it is simply equal to 2 to 1 with weight 6 also. Even then, for example, if this is the only graph, even though we add the adjacency list with weight 6, we will not use. What is the problem? There is nothing problem, right? But whenever there is a reduction, we want to use that. So if in this 1 to 3, 1 to 2, we have added 3 and we have added 6. So for 2 to 3, the weight is 4. But for 3 to 2 also, there is an extra which is 8. So even for 3 to 4, we have 5. And then for 4 to 3, we will add 10. And then we have 2 to 4 as 1. 2 to 4 as 1. And then we also have 4 to 1 as 2. So in this case, we can directly use dash to right. So we can come from 1 to 2, which is 3. And we can go to 4 with the cost of 2. So in this way, even if there is no use to add every pair reversal edge, but if we try to do that, we can directly get answer by dash to. So simply for every given edge, add u to v with a weight w that is given, and for reverse, add 2 into w. So in this way, we can get answer. So hope you know what is Dijkstra. So it is used to find the least cost from a given node. For example, this is one, and we have many different possibilities. For example, this is the given one, and we have to find the minimum cost to reach 5 from the node 1. So initial cost to reach 1 is 0 because we are at one initial node initially, and then we can reach to 2 by the cost of this. We can reach to 3 by cost of 1 3. We can reach 4 by cost of 1 4. So in these three, we will select the node with the least distance from the given initial node, so that every time we update the node, we will get the least answer for that. So for that step, we can maintain a simple distance vector where distance of I is the distance of initial node 0 to that node. So initially distance of 1 is 0 and all other are -1. So it means that there is no path between 0 to that node initially. So in this way, we can try to use a distance vector, and then we can start from node 0, and then we can use Dijkstra to get the answer for each and every node. So hope you got this. If you have any doubts, comment below. See you in the next video.